Welcome back to the channel, everybody. I'm Dino. If you've been following my series on how to sort of run a small restoration project to make it successful, you'll know this is part 4 of that series. Now, the first 3 parts really covered how to determine what you're going to do with the project. In this case, I separated the engine and frame and restored the frame. And in the last episode before this one, we went over the engine and got that engine running, and I gotta tell you, it runs really well. However, it was a little disappointing when I plugged something into the generator. There was no power. Now, I know my way around a gas engine not too bad, but electrical generators, it's a mystery to me. So I called a friend who came over and walked me through the steps to actually determine whether or not this generator should be producing power and whether or not he thinks we could get it running. So you're going to have to stick around to see if we were successful. But I will tell you, we had a lot of fun and I learned a lot about these systems. And that's really what this series has been about. It's not really about the generator. It's really about your project, what you're working on, and again, how to keep you on track so you're successful. So sit back, grab something cold to drink. This ought to be fun today on Dino's Tinker Shed. This will be good. So this project really should be called determination, because up until this point it's been fairly smooth sailing, but the generator unit itself gave me some really hard challenges to overcome. And I think that's really what this whole series is about. It's about fortitude. It's about digging in and trying to solve the problems. It's not really about how to fix something, but rather how to get your mind into the right mindset to fix something. So I got so frustrated at one point that I set the generator aside. I called up my daughter and my son-in-law and I said, look, I can't seem to get any power to this generator. It runs great, but we might need to just sort of go out and look at a different unit. And that's what they did. They ended up buying a Gen Pack unit for their house that's propane powered, because they couldn't take the risk of not having a generator out at their house. So the generator sat there for a while, and eventually I started reading a little bit on the internet. So I slowed down the process and I took a little vacation, if you will, from the project. And that's something I encourage you to do. If you hit a roadblock where you just cannot seem to get through it, take a step back, put it on the shelf, and let it sit there for a little while and think about what your next step is. So I decided that if I couldn't get it running, I wanted to understand why I could not get that running. So I called my friend up and he did come over and help me to trace the unit out. So we went through and looked at the different legs of the generator circuit, the 120 volt legs, which ultimately combined into the 240 volts. And they seemed to be pretty good. We tested the capacitor, which looked brand new. I have a feeling it was put away with a brand new capacitor in it because somebody was trying to get it running and they couldn't get it running. Capacitor on these brushless generators apparently is one of the first things that happens to go on them. So that looked like it was in good shape. And eventually we were able to reach an end to the project. So, we were able to get it running. And it's interesting how we got it running. And I'm sure people who have fixed these generators before are going to say, it's this or it's that. You need to do this. You need to flash the system so it the residual magnetism comes back in, and then it'll get, we'll look at all that through a video here. But for me, it was really interesting. It was a little bit humbling, actually, why it wasn't generating power. And it wasn't a circuit breaker. Some people will say that. It wasn't that. So anyway, let's get started. And I think we'll start by taking off the end of the generator cap so you can see what's underneath there. Again, We're not going to go through all the diagnosis. This isn't how to fix the Jenny unit so much as how the problem solving, the thinking went to get to the end result. So I hope you enjoy it, and we'll get to work now. Great. Thanks. Okay, as I wait for my friend to come down, I'm going to take the end cap off the generator. Now this leg here actually runs up to the capacitor, which we're going to have to test. But you can also see other parts of the Jenny. This part down here is the 12 volt rectifier. These lines that are coming out should be 12 volt if it's running right. And these three knobs here, three nuts, are the two legs of the 120 and 240 volt AC lines. So we'll be checking those as well. Now as my friend comes over, I'm going to disconnect this and see if I can test the capacitor. I know how to do that. Now if I understood the size of the capacitor, I could test it right here just at this plug, but I don't. So I'm going to have to take apart the control panel, and I want to paint this anyway. So I'm going to pull these screws out, and then this should give me access to the capacitor. Let's see here. I'll just see if it pulls out. Yeah, there it is. It's tucked right back, that blue cylinder. But there's a lot of wires here. So I think I'm going to start taking a few photos at this point, because I want to make sure as I take this apart, I get it back together. So I take a few pictures inside just to let me know how the wiring actually should go. It looks like a bowl of spaghetti here, but it's actually not too bad. So I'll start taking apart the control panel itself right now as I wait for my buddy. And it's just methodically taking it apart, unplugging all the wires, taking my time, and you know, any plugs or connectors that need to also be disconnected. And I think this one just about frees me up. Yeah, I can put this on the bench. Oh, I got one more thing that's stopping me. This was an interesting little pin that connected this 240 volt breaker. It had a little connector pin across there that had to come out in order for me to actually finally remove the control panel. There we go. So to get the capacitor out, it's really only held in with this one strap. Now capacitors can be dangerous here. I have to warn you, if it has any kind of a charge in there, it's basically a huge battery that discharges really fast. So I'm going to gently pull off the connectors, and then I'm going to use my screwdriver here across the two contacts to discharge any stored energy that's in this capacitor. Now on the capacitor itself, it looks like a brand new capacitor. I think this has been changed. There's no swelling or leaking or anything. And you can kind of see on here, it tells you what it is. It's a 450 volt AC capacitor running 50 to 60 hertz. I have no idea what this number is. And the number that I'm really concerned with is the one at the top here, this 30 UF plus or minus 5%. So this is 30 microfarads plus or minus 5%. So we can test this. This really inexpensive multimeter that I bought off Amazon has a microfarad setting. It's right, let's see, oh no, one more button please. There we go, microfarads. So I can test this. Now, because this is an AC capacitor, there's no continuity requirements. So basically you just touch the leads to one of each of these two poles with the red and black leads, and then the microfarads will be read on the multimeter here. It just takes a second, and look at that, 30.05. So we're right in spec. This capacitor is good. This isn't the problem. So as I wait, I further disassemble this cover plate. I pop out the hour meter, and what you'll see is, because it's labeled, we know which way is up. And I leave the screws loose here, so I know these are the connectors. These ones are still tight. I don't need to touch those, but when I put it back in, I know which ones are the loose connectors. I'll take these LED diodes out, set them aside, and then I get to the key switch. Now, once I get to the key switch over after this diode here, what you're gonna see is it's got a special ring on it. I didn't have the right pin wrench, so I gingerly put a set of vice grips on here, trying not to crush the washer, and it should come out. And you can see it's got a little detent here that lets you know where it's going. Okay, that looks pretty good. I don't know if this, I don't believe these, I think these are painted on. I don't think these are stickers. They're not a decal. They're definitely painted on there. So I think I can probably replicate the majority of it by just sort of stripping and repainting this a matte black. I might even go from here over. It's hard to tell. It really is. It really is a hard thing to do. And I'm not much of an artist, but I do have some clear white labels that I think I can make a reasonably good facsimile to label these. So anyway, I think that's what I'm going to do. So let's get to work on that. So in order to paint the control panel, I'm going to mask off the areas that I don't think I want to paint. I want to try to save some of these graphics. So I'll just use some good quality painter tape, and I'll lay strips across here, making sure to cover and overlap really well. I don't know if this is going to look good or not, but this is the route that I think I'm going to try. I'm going to try this stripping disc here first. I'm going to go right to this. And I've had good luck with these over the years. We'll see how this works. Okay, this one's made for Canadian Tire here in Canada. I think it'll strip everything off really well. Let's try it. So I think next I'll switch over to one of these flap discs here, and I'll try to get off as much of that rust as possible. Now most of it's gone after that stripper disc. And then I'll follow it up with one of these, which is a Scotch-Brite disc, just to polish it. And I'll probably get out my small roto-lock attachment to do all these little areas here. Okay, let's get going. Okay, I'm going to just clean the area up now with some rubbing alcohol. I'm going to put it on a rag here and just clean it off. And you'll see there's quite a bit of dirt that does come off of this after the grinding process. Once I'm done here, I'll use a little bit of direct to metal primer that helps seal the rust out and should give us a nice coat. Okay, there's the first coat of primer. I can hit this again in 20 minutes and give it another thicker coat, but it looks pretty good. So I think I might move right from the primer to the top coat. Now I am using a rust paint. I think it looks pretty good so far. This will give me time to cut the grass. I can come back and then put a coat of paint on. See, multitasking. It's part of a good project. Okay, I've got 2 coats of paint on here, and I am going to pull off the masking before the paint dries. That way you get the best line possible. So I don't know if this looks good or not. It's kind of looking to me now that I look at it. But we'll see. I might just... Man, oh man, oh man, now that looks just like crap. Oh, it might be better just to paint it all. I was thinking I might be able to do something over here, but this just looks like crap, doesn't it, everybody? Yeah, I think I'll wait for this to dry, then I'll sand this off, paint the whole thing again. Okay, I think the paint turned out reasonably well. So I'm going to use this Brother labeler with clear tape to print white letters that I can then stick onto the control panel. Now you can see that these letters are not going to look as professional as the original lettering, but they also don't look too bad. And I just take my time and place them with tweezers as best I can to get them straight. Now one tip I've learned is if you know all of the different letters and words that you want, print them all off at once. It saves tape because these printers have a little bit of lead on the beginning and end of the tape that adds up to quite a bit of cost. Okay, I've got the labeling done. I'm going to go through and clean the inside of the control panel and reassemble it. This is where those photos actually were very handy, especially when I got to the LED lights and the way in which the 12-volt system worked. I had to reference them quite a bit. But I just took my time, put everything back together, and I think it looks pretty good. Now, I got some brand new Phillips head screws, some pan head screws, and replaced the ones that were a little bit rusty. It helped add to the overall quality look of the piece. I think it kind of looks like an aircraft dashboard now. I don't know. I like it. What are your thoughts on it? Well, I still had some time on my hands. I thought I might as well wire up the electric starter. So I used some 8-gauge wire that I had here. I would like to have used something a little bit heavier, but this is the heaviest wire I had. And I grabbed some heavy-duty lugs here out of my collection. And I just basically made a wiring harness that runs from the starter all the way back to the battery tray. So I just thread these lugs on, and then I crimp these down. Sometimes I'll actually solder these in, but for this particular application, I think this works quite well. So this tool I have, you just basically orient it in the right direction and you squeeze. And this is a nice ratcheting one. It's a very good quality tool, and you can see it makes a very firm connection. I'm going to follow this up with a little bit of heat shrink for two reasons. One is it does help to seal it. It adds a little bit of strain relief, and I think it just looks a little more professional when you seal the ends of it with heat shrink tubing. And I just use a heat gun here to shrink it down. I'm going to take both the positive and negative leads and drop it into some of this protective coating. This stuff really works well. It's like one of those finger puzzles. Once you put it in, you can't pull it out. So it's going to offer some abrasion resistance and also some strain relief. And then I hook it onto both the ground and the starter underneath the dash here. So these are the kinds of things when you're doing a project that's really fun. You can make this look really, really professional. And when you step back, it just looks good. So I'm going to use another little bit of heat shrink here to seal the end of this sheathing. So this is very heavy heat shrink tubing. It takes a lot of heat to shrink it down, but eventually it does. And I just cap it with a little bit of black electrical tape just to add a little more strain relief. And then my favorite part is using zip ties. I'll zip tie this along the frame rails all the way back to the battery tray. You don't want to over tighten these, but they need to be snug enough so that they hold the cable steady along the frame rail. And you can see that sheathing looks really good. I'll finish this up with some more lugs and some more heat shrink tubing, and then I'll use an old DR650 battery here just to try it. Okay, my friend arrived and we started to do some testing. So I set my multimeter to the ohm scale and test it. So you can see it comes in around 0.3 ohms without any load on it. So you need to remember that. First thing we do is we check the capacitor leg. Now it comes in, you'll see here, at about 1 ohm of resistance on that capacitor circuit, minus the 0.3, so that makes it about 0.6 ohms of resistance. Now, my friend could not find an ohm sheet for this specific generator that gives us the values we're looking for. So we're kind of just looking to make sure there's no really high ohm readings. The next thing we do is we're going to check the two 120 volt legs. So you can see that's 0.3, so it's almost zero resistance. This one I think was about 0.6 minus the 0.3 is 0.3. Ohms of resistance, and then when we go across both the 120 volt legs, we come in again around 0.3 or 0.4, somewhere in there. So the ohms readings were quite low on this. Now we also have to check the continuity between all of these to make sure nothing's touching ground. So to do that, we use our continuity tester. So you can see I can test all the legs of the main AC circuits as well as the capacitor circuit here and nothing grounds out, but if I do touch the scale, it makes a sound. Okay, next I'm going to fire up the generator and see if there is any output at all on this. Now the first place we're going to start is at the capacitor circuit. So we hook up our AC line here and we check it, and we have 2.5 volts of AC power coming out of that. That's good. We need some for the capacitor. Next, I'll check the 120 volt legs, but I realized I didn't have the capacitor hooked up. So I hooked it up and tested it again, and we were getting no voltage, 0.9 volts AC. So this is about the time I got completely frustrated. We had good ohm readings on the generator unit itself. It didn't appear to have any physical damage, and yet my friend and I could not get this thing to generate power. The most we could get was about 2.5 volts coming to the capacitor. So I set it aside. I called up my daughter and I said, I don't think I'm going to get this thing going. I think it's beat me. There's got to be something that's either the diodes on the rotor or something are gone. It's maybe beyond my skill level. And I sat down and left it for a few days. And this is a good thing to do if you get frustrated with your project, is just smell the roses for a while. Take a break. Let it aside and think about things. I did a little bit more research, and what I found was this style of generator that uses a capacitor is really supposed to have about 5 volts kicking out to the capacitor, in which case initiates the magnetic field on the main windings. Now with only 2.5 volts, it obviously wasn't going to have enough horsepower to actually get this field started. And the further I read, the more I realized that RPM plays a huge role in the way these generators work. So this particular engine is a clone of the Honda GX390. That's supposed to have an operating RPM range of around 3,600 RPM. So I thought, why don't I go out to the shed and see what this thing's actually running at when it's operating. So this is what happened. So I'm going to use this little temporary tachometer here to understand where I'm running. So this uses an induction cable that wraps around the high tension lead of your spark plug. And you basically just wrap it around 4 or 5 times. I tie it basically in a taut line hitch basically around here. And I also am going to try flashing the main rotor on this thing with a little bit of DC power to see if I can induce some magnetism. So I try it without the engine running. I put a little bit of 12 volt battery power, and then I start the engine up and I try flashing it again. So basically what this does is this flashing process. You can see I'm running around 2400 RPM here, which is really low. I flash it and it induces the magnetism, and you can see all of a sudden I'm getting around 85 to 90 volts. So I'm just going to use the throttle adjustment here and turn this up and see if I can get the RPM up to 3600. Now my tach seems to for some reason be running at half speed here. So I need to raise the RPM up to about 1800 RPM. You can see here. So that gives me 120 volts. Fantastic. Well, that about wraps up this project. I think we took a piece of equipment that was looking kind of rough, wasn't running, wasn't producing any electricity at all, and we now have a piece of equipment that looks reasonably good, runs fantastic, and produces electricity the way it's supposed to. So whether your project is a generator, a motorcycle, a snowmobile, whatever, I'm hoping that this series helped you to see that perseverance can get you to the end of those projects. And really what it takes is some organization, a work plan, and when you get into trouble, the guts to call somebody for help. And that really got me out of a jam here. If I wasn't able to call my friend to come over and help me trace out all of the legs of the generator and confirm to me that that unit should run, I probably just would have given up and we would have trashed the generator and pulled the engine off it and tried to sell it separately. But instead, through some reading and setting it aside for a while and letting my brain rest, was able to actually come up with a different strategy and a different way to look at the problem, which in the end generated the result I was looking for. So I wish you all the luck with whatever projects you're working on. I hope you get out in your shed or your garage or down in your basement and work on something fun to learn and build your skill sets. I'm thrilled that during the production of this last episode, I crested 340 subscribers. I have to thank you for helping me achieve that goal. It's fantastic, and I love watching the sponsorship or the subscribership go up. So until next time, I'm Dino. You have yourself a great day. I will see you soon on Dino's Tinker Shed.